Good afternoon, everyone. I'm Kevin Carpenter, volunteer at CppCon. I'm here with Stephan Lavavej, STL, which I just have to kind of joke about because, you know, you're the program manager for the STL at Microsoft. That had to be a great
the developer who's worked on it the longest.
Oh, I'm sorry. So my apologies to whoever's title I just took out. But it always made me laugh when I would see you doing a talk on the STL and your initials were STL.
Suspiciously convenient.
Yes, absolutely. So I was looking at the archive getting ready for talking with you today, and I noticed that I think the only CppCon I didn't go to is the only one you didn't present at, which makes me think you've got a perfect record of attendance for the convention.
Perfect as observed by you. I actually didn't attend CppCon 2017 for family medical reasons, but I've been at every other one speaking. And I also spoke at Going Native 2012 and 2013, which was kind of the precursor to CppCon.
Oh, I got you. Yeah. So, well, that's interesting. I guess we both missed on that year then.
Yeah. I wish I had attended. There were some cool talks I saw in the program.
Yeah, that there was. And I likewise missed for similar reasons, but we're both going to be there this year. And the reason that I have you is to talk about your upcoming talk. Mm-hmm. But before we get to that, I guess the question I would ask, since you've been there so much, there's two questions to this actually. First, what is it that you look forward to the most when you go to the conference?
I think being able to meet people who use the code that I work on all day is one of the really cool things. You know, I mostly hear from users, you know, through Twitter or who file bug reports. But when I go to CppCon, I get to see users who aren't complaining about, you know, a particular bug in our implementation. People are just like happy with the features that we write, and they're using them for really cool things in, you know, the medical field, in, you know, geographical, you know, information databases, all sorts of, you know, game programming, you know, things that, you know, I've never directly worked on, but it's really cool to, you know, hear how they're using C++.
Yeah, I will say that, you know, I know that in the times that I was working with Microsoft Visual C, it was always awesome to be able to use those algorithms, because I remember the times way back to Borland before, you know, the STL was really being used that much and we were stuck with ANSI strings. So even with MFC, it was nice to be able to pull in the STL to handle vectors instead of doing arrays by hand and such. So,
yeah, especially with the STL's attention to computational complexity. For a long time, if you used MFC C array, it would actually resize in quadratic time. And the STL has always provided linear time pushback, amortized.
Oh, wow. And it's funny because, you know, as an application developer, those are the kind of things that I get to learn because I get to have conversations like this with you. It's interesting because there's a lot of that code that, you know, when I first started using it there, I didn't really know. It was just more the ability to have such a common interface and pass objects around that I was excited about. So another question for you, for new attendees, what's one of the things that you would recommend? Anything for hints of advice?
I would say first, like, use the sched.org scheduler planner. You know, take an hour or two before the conference and really think about each time slot and which session you want to attend. Having that all prepared ahead of time means that you can just focus on, you know, finding the next room rather than furiously trying to choose between like 6 talks, depending on how many tracks they have. You can always change your mind later, but being able to, you know, tentatively select what you're going to see is really cool. And then when you're actually at the conference, I recommend usually right before like the lunch break, people will start to mill around in, you know, the large common areas and break off into groups to go to lunch. Try to go to lunch with, you know, as many different people as you can, different speakers. You know, we're just humans. We have to eat. And that's a great chance to, you know, spend, you know, half an hour, you know, talking to people about usually C++, and, you know, learning what they work on and all sorts of, you know, insights that you wouldn't necessarily get from their talk. I know I've learned a lot just from, you know, talking to other people I've just gone to lunch with. And then I'll attend the next CppCon. I'm like, oh, I remember your face. We went to lunch together last year. And that's really cool.
Yeah, I have to say this last year with volunteering, that was one of the things I'd have to agree with you with. The chance to actually sit around, you know, I enjoyed it because whenever you needed help, you just look for someone in one of the blue shirts. So we get a lot of people coming up and asking questions. But then with the speakers and everything, just to be able to sit around, talk about what you're up to and what you're doing, that's probably even more so, because you take that away a lot more, than the talks themselves. You can always go back and listen again too. So
yeah, but they're not going to record those lunch conversations.
absolutely. So your talk this year, floating point charconv, making your code 10 times faster with C++ 17's final boss. Now, the final boss part, if I was reading the abstract right, I'm guessing you're calling it that because it was the last piece that you guys got into 17 as a feature?
Yeah, it's kind of the last piece to be standardized, but it's definitely the last piece to be implemented. When the library working group voted this into the CS+17 standard, I think it's safe to say that none of us in the room, myself included, really understood what we were getting ourselves into. It looked like a tiny little feature, kind of like printf. Maybe it'll take a couple weeks to implement, and it has taken about a year for us to implement it. And currently, MSVC is the standard library that is the furthest along in implementation. We're almost done, not quite. And it's actually the only thing in the library that remains to be completely implemented. So I think the title Final Boss is quite appropriate.
I would say so. So with all the stuff that you end up working on, I have to ask, was it easy to pick this over other things that you could have probably done talks on?
Well, it's sort of like it's been my entire life for the last year. So if I'm going to give a talk, it's generally going to be about like what's at the top of my mind, what I'm immersed in. So it's either really talk about CareConv or nothing. Unfortunately, it's a very cool area. I've learned a lot while looking at it, and I think that there's a lot for people who will just be using the library to learn about. Because one part of working on CareConv has been learning the algorithms involved, learning the domain. But also part of it has been sort of fixing my misconceptions about floating point. I used to, I think like a lot of programmers really fear floating point once I'd become like intermediate level, because I'd heard about, all the potential gotchas, like, oh, 0.1 plus 0.2, what is that? Maybe, when I call a function, it's going to return a slightly inaccurate answer. And it just seemed to have so many, minefields. I'm like, I'm going to just keep sticking to integers because I know how integers work. They're friendly, and floating point seems like it's full of razor blades. And forced to implement CareConv, I've had no choice but to learn how to, avoid the razor blades. And actually, it turns out that some of the fears that people have about floating point are misplaced. It's definitely a complex area, and there are things to be on guard with. But I think that once you really learn how floating point representations work, half of that fear is actually misplaced. And the nice thing about CareConv is, yes, it's incredibly difficult for implementers to put in the standard library, which is a good reason why it's in the standard library. Let's get it right so nobody else has to ever deal with this. And then you gain access to this incredibly powerful family algorithms that lets you not only format these numbers incredibly quickly, like unbelievably fast, like the 10 times faster in my talk title, that's not a joke. It's literally an order of magnitude faster, sometimes more. But also you can format numbers in a really elegant way that's human readable, and that's really novel. Algorithms to do this have existed, but they've never been available in either the C or C++ standard library, and CareConv is going to make it available on every C++ implementation.
So I have to say I'm actually really interested in it because, at least from the market that I worked in, I used to do financial simulations for credit unions, and we actually used a lot of doubles because when you're calculating interest rates on billions of dollars, you're easier to go backwards in the accuracy by using deeper decimal places versus these large numbers. Mm-hmm. And so, to your point about fearing the doubles and the float types, we definitely ran into a few of those gotchas where, a decimal point off could be a couple $1,000s difference. Mm-hmm. But from our case, we used them and tried to make sure that we used them right. The speed and performance, I do know that the company that I was doing that with before, they're going to look forward to this because the amount of stuff that they print out is just exorbitant. So I'm sure that's going to be a feature they're going to enjoy. So when the attendees come to the conference, or come to your talk, I'd say, aside from the 3 times to 10 times speed up, what other takeaway do you think that they'll enjoy from it?
I think the takeaway is that although you're going to be using what is actually the largest implementation in our standard library, just in terms of sheer code size, not even counting the large static tables that drive this, conceptually, the interface is quite simple to use. It's It's non-null terminated, so you can fit it into more applications than the C library can be used with, because C's printf and std, they insist on working with null terminators, which can be somewhat inconvenient. And charconv does not require that. And then it's just a matter of being familiar with the different format options. You can choose fixed or scientific notation, or a couple of overloads that switch between fixed and scientific in a visually pleasing manner. And then when you learn what it means to select the shortest round trip decimal format, then that allows you to format floating point numbers without having, like something like 0.9999997, instead printing something nice like 3.14, 1.729, and yet you're guaranteed that you're going to be serializing the entire information content of that double. You're not going to be dropping any bits by rounding prematurely. And that's the really cool thing that these algorithms do.
No, that absolutely is. That's actually really exciting. So
yeah, I'd say two kinds of people will be most interested in the talk. One is people, like you mentioned, who have to just print out a whole bunch of floating point numbers. There, the speed up is incredible. It goes from being potentially one of the slowest parts of the code to so fast that you'll instead be bottlenecked on your disk or network speed. And the other class of programmers that should be very interested in these functions are ones who are going to print out floating point numbers for users to read, and they want an elegant format. And that's where the shortest round trip format can be useful. Anybody working with floating point day to day will also find insights here. But in terms of like actually using the library, it's either the speed or the visual simplicity of shortest round trip that are the most interesting.
That's excellent. So with that, I guess we'll look forward to seeing the talk in September. And I appreciate you giving me time today, and thank you so much.
Cool. Yeah, thanks for chatting.
Talk to you soon.
See ya.